Hello folks, we're going to go ahead and get started. So welcome to the webinar for how to avoid microservice pitfalls. ClearMeasure and Particular Software have teamed up to present this webinar. And so you can get the code at github.com/ClearMeasureLabs, and we invite you to do that. There's a README there. And if you have Visual Studio 2015 and SQL Server Express 2014, then you can follow along. So why don't we just dive in. So my name is Jeffrey Palermo. You can see me on Twitter, jeffreypalermo.com, or excuse me, at Jeffrey Palermo, and I'll be here with Justin Self and David Boyke, and you can see the Twitter handles there. Throughout the webinar, you'll be able to ask questions in the Q&A panel, and we're going to do our best to answer those during the webinar, but we commit to you that if we don't get to all of the questions during the webinar, then someone will follow up and you will get your question answered afterwards, if that's the case. We will have a little bit of time after the content to answer some targeted questions. So go ahead and feel free to put in questions anytime that you'd like, and we'll make sure that we get those answered. All right, so we're going to start with what is and what isn't a microservice. First of all, it is a service that encapsulates one capability or function, and probably everybody familiar who's here is familiar with a system that got out of control, that got too large, that maybe served multiple departments in the company, multiple constituencies, and we've come to call those monolithic systems, where they're tied together, coupled together. One department wants high performance during business hours and doesn't work at night, and the other department works 24/7 and has to have it always available, and so you're always trying to find a maintenance window for when you can deploy, or maybe the whole system has to have no downtime deployments, even though 75% of the user base might only work banking hours. But either way, if the microservices architecture has come along so that we can separate and decouple these various concerns and have units of deployment that encapsulate only one capability or function. And what it isn't is a service that has multiple responsibilities. I want to call out what we're not talking about here is having one microservice per user story. That would obviously be insane, and we want to make sure that as we move away from monolithic systems, we don't end up with a pendulum swing all the way to another equally disastrous extreme, where instead of having one large system, we end up with hundreds of small little applications running around in production with a dependency management nightmare. And so typically, you're going to have a handful of microservices unless you have a very, very large system. So we wanted to level set with what it is and what it isn't.
I think one of the things to note on here is that a lot of people try and get caught up with how large is a microservice. And people start thinking about, well, how many lines of code does that mean, and how many files and all that stuff. The point isn't to limit based on the physical nature of the microservice, but just bringing it down to one capability, one function that you're working on for this. So that could be several hundred lines of code. It could be just one code file if that's all it needed to be. But the idea is that it's a single responsible entity.
Absolutely. All right, so we're going to get started and talk about some microservice pitfalls. These are common problems that we've encountered at ClearMeasure. We've seen them and gotten around to them, and certainly implementing NServiceBus and particular software, we've seen lots of instances of these, and they're the most common ones that, while they're very easy to get around and very easy to avoid, we have to think intentionally about them. Because if we don't, then they can waste our time or have quality problems. Either way, life not happy. So we're going to walk through each one of them and give you some guidance on how to get around them and avoid them. Okay, so the first pitfall that we're going to discuss is having more than one microservice in a repository. So microservice is a newer term in the industry for this type of distributed architecture. Everything that we talk about here is going to be discussed in the guise of a distributed system with messaging and asynchronous processing powered by NServiceBus, so the examples will be as such. But a lot of the same principles apply when you're talking about distributing a otherwise monolithic system into individual applications. And microservices are a style of decomposition into these applications. And so the same principles apply whether you're adopting a microservice architecture or whether you're just integrating two applications. And that is one of these things in a particular source control repository. You don't want two of them. If you do, you're going to have difficulty enforcing complete separation. You're going to have accidental coupling if you have them in the same source control repository. Your builds are going to be really complicated, and you're going to end up creating more custom code and more custom configuration to separate two microservices in the build and deploy process. And every tool under the sun, the Git repositories, the versioning tools, the build tools, the continuous integration servers, the deployment tools, they all work under the prime scenario that there is one application of any type, regardless of architecture you choose, in a source control repository. And they're all built to work really well that way. When you deviate from that convention, you're on your own, folks. You're going to have lots of problems because you're going to have custom configuration and custom convention because the products and tools are no longer going to work for you, but you're going to be trying to jam them into a scenario that they weren't primarily designed for.
All right, so our guidance here is one microservice per repo. Most of us are probably using Git or we're either using Git or we're thinking about using Git and just haven't moved over the edge. All of the major players in this space, I'll give you basically free repos now as long as you go for the subscription model. Having one microservice per repo really allows you to simplify the CI/CD pipeline. Otherwise, you have to start doing these interesting custom checks to see which project change, which app inside the microservice or inside the repo are you going to version in a certain way, and then deploying those independently becomes very difficult too. Another great benefit is that it gives you a really focused history about all the changes for that particular microservice. For example, if we've got two of them in one repo, that means two different teams could be working in that area. You've got a bunch of history that doesn't relate to the actual service that you're working on, so it just kind of clutters it up. That's not necessarily a bad thing, but it's a much better thing to have it focused because you don't have any kind of superfluous commit throwing off anything when you're trying to figure something out that happened previously.
I think it's really also important to point out that having your microservices in multiple repos can have organizational benefits too. One of the things, by the way, this is David Boyke at Particular Software. One of the things we do is in NServiceBus 4, we had all of our different products all in one repository, and that meant that every time you changed basically anything anywhere, we had to release new versions of everything. And so now everything is split into multiple repositories. So for example, the unhibernated adapter is in a different repository from the core. And this means that we can have different maintainer groups that pay attention to these repos in GitHub and gives us only insight into the things we're actively working on.
All right, and I'm going to show you real quick, we have basically a standard way that we bring up our repo organization. I'll just show that to you real quick.
And so this is the code from github.com. So if you're in front of your computer with the dual screens, we invite you to pull down that code and follow along with us. You'll be able to run the build and pull it up in Visual Studio and do everything that we're doing as well.
So here you can see we break our stuff up. And this is pretty standard way that we start to see this stuff happen across the industry. We have a source folder, which is where all of our code lies. We've got a build folder, which has particular build tools that aren't necessarily coupled to the source code. So we try and break those dependencies out. We don't need the build tools to run the code, so we put those in a different folder. Then any miscellaneous tools that we include with this go in there. And all of our repos typically have this click to build batch file, which just fires off a Saki command. It kind of gives us this nice consistency going across, and everything is focused on supporting this one application that's in the repo.
And this is one microservice. So we have a Git repository, which includes one deployable unit, one microservice. And again, a microservice can have multiple processes running in production, but it is one unit of deployment. We're going to release this on a particular cycle, and it is going to be completely independent of other microservices which may have different release cycles, and the dependencies are going to be managed as you would managing from application 1 to application 2, because a microservice is a unit that is equivalent to an application, and multiple applications make up an overall software system.
Yep.
Hey guys, we've got a question. Matt Ridgway asks, would Git submodules be an acceptable way to pull the lot if you wanted to be able to pull/build an entire new infrastructure, say for a white label environment or a new developer joining? What do you guys think about that?
That could be a possibility. I wouldn't say that it's a must. When there's plenty of techniques for aggregating builds at the system level, and certainly you're going to have to give that some specific design thought. However, just having multiple Git repositories and modeling each one with its own continuous delivery pipeline is all that it takes in order to orchestrate this. So it doesn't require any complexity and any integration at the Git level in order to make a microservices architecture work. So if that works for you, that's great, but I wouldn't say that any Git level integration is necessary at all if you don't want to do that.
All right. We'll get back in here. Okay, our next pitfall.
So the next one is more than one microservice per database. And when we say database, we're going to say data store in general, but we're just going to use the term database. And the pitfall is not starting out a microservice with a way for it to store data that it owns. Think system of record type data. It's not data that it's a copy, but it's a data that truly resides in that particular microservice and that it needs for doing its work. And so if we don't provide a private repository that microservice owns that nobody else has access to, then what ends up happening is we crop up dependencies between other microservices and other applications. Because if a microservice is developed with no private database of its own, then developers end up relying on other databases and then crop up connection strings and network file paths or whatnot, and then start using data stores that it doesn't own, and then we have dependencies that get out of control. And so when you have data storage level dependencies that are not properly managed as inter-application dependencies, for instance, there's a whole movement around API management, and certainly queues between microservices, they always have an owner. So any dependencies and any connections between applications of any type need to be managed explicitly. And when a microservice is not given its own database, then it ends up cropping up these storage level dependencies that weren't intentionally designed from the start. And we end up getting not just spaghetti code, but possibly a spaghetti system.
So our guidance here is each microservice gets at least one private data store. And the big things that this allows, if you use one database for all of your microservices, let's just kind of think about SQL, because that's a very common scenario. We try and stuff everything into a relational model. That means that if we have any data that's shaped as a document, or that would be better suited to be put inside of a graph database, we are trying to break up that data model and make it relational. So it forces us to try and think about it in those relational terms when it doesn't need to be. So allowing each microservice to have at least one private data store, we get to pick the right tool for the right job. One big question that comes up, though, is, well, how do we start to aggregate some of this data for reporting? Typically, we'll expose APIs, or we'll use NServiceBus events to propagate data across services, maybe going back to some star schema, adding fact tables and things like that. But one big thing here is when you start to do this, there is a management complexity around managing the different databases that each microservice can have. So this needs to be automated as far as how those microservices update the database, how they update the schema, adding in the indexes, doing document patches, and all that. So we're actually going to show you real quick just a little example. There are several tools out there that can help you with adding migrations for databases and upgrading schemas. And we're going to show you what a common one that we use is. So right now, I'll show you our little sample database.
And the tool is called AliSQL. If you've heard of Roundhouse or Redgate's DLM, or there's plenty of tools that do the same thing. This is a free and open source one that we happen to contribute to, and it's super, super simple.
So right now we've got an NServiceBus webinar SQL database with an order column, and right now it's just, or an order table, sorry, and it's got an ID column. So what we're going to do, and again, this is all available in our Git repo, so you can bring it down and see how it works. We're going to create a new SQL migration script. 0002 is going to be the version number, and we're just going to add customer ID to order table dot SQL.
And the key here, again, this is a continuous integration principle. Absolutely everything in your microservice needs to go in the source control repository. So that includes database schema.
So here we just have this little update, just a little SQL script. All right, so we're alter table, order, add customer ID. This is, of course, just a trivial example, but now I can come here to our Saki script, and we're going to let this compile everything, and it's actually going to run test 2. And then it will update our database, and that way we don't have to physically have a DBA go through and try and manage where all the databases are and update scripts and update schemas and things like that. So if I bring this up now, here we go. Now we have a customer ID.
And that was really quick. I want to just express how exciting this is. If you are one of those people that live in a world where when a database column changes or something in the database column changes, you have to send out an email or maybe call over your cubicle. Hey Bob, I just changed the database on dev, so don't pull the code until you're ready to do it, or you need to pull your code now, and it's all manual. In this way, if that new schema change script is pushed into the source control repository, the rest of the team just has to pull the latest source, run the build, and every local dev's database is going to be upgraded with that new column, and nobody gets a broken compile. That's really exciting if you're moving from, or if you're working in an area right now where you do manage those database schemas offline or out of, not integrated with your source control.
Hey guys, I got a couple questions before you move on. What was the name of the free database tool you mentioned?
It's called AliSQL. It's AliasQL. And it's a NuGet package, and you can also find that on GitHub. Other alternatives that work very similarly are Roundhouse, which is another popular one.
Fluent Migrator.
Fluent Migrator. So the principle is there is a directory in source control that has just a number of SQL files, and in this case, it's in database scripts and update. And it's just a number. Now, by convention, all these tools use alphabetical listing, and that's why you put the number in front of the SQL file name. And so in alphabetical order, the tool runs through each SQL script, executes it against your local database, and of course, when you're deploying to dev and test and eventually production, this is the exact same process, so that by the time you do it on production, you've run this exact same process multiple times, and it's been well tested. And so that's the general principle. Several tools that sort of employ the same design, but we're just going to run through in alphabetical order and then record in a little small table, a log table in the database, what scripts have been executed against this particular target database so that no script ends up executing twice.
Okay, and another question. Let's see, where did it go? Someone was asking to talk a little bit more about using a schema within a database to provide database separation rather than actual separate databases.
Sure. That's let me take this. So that's I get this a lot. So that Literally, yes, you can do that. The reason we suggest having separate databases is we don't really want to introduce the complexity needed to manage permissions against the schema, and we don't want to introduce the option of making it super easy for people just to reach over and pull something from another column that they don't own. So yes, the answer to your question, you literally can use the schema. There's nothing, nothing's going to stop you from doing it. You can even do this completely schema list, just use DBO as your default, but we're trying to get around conventions that enforce this and make actual physical configurations that enforce this separation.
And from an architecture perspective, we can go back to the slide, our pitfall is when you develop a microservice and don't give it any place to store private data. And so that could be a directory, that could be its own, it could be a document database, and it could be a SQL Server database. So the microservice really needs to have its own private data store for data that it doesn't share with anybody else but needs to do its job. And so it's a very, when you're talking about SQL Server, it's a very well-worn pattern to have each microservice, and even if you just have multiple applications, each application have its own database, and then when you go to deploy, it's totally your choice if you choose to deploy multiple databases on the same database cluster. That's perfectly fine. So if you want to compress the installation at deploy time and have them operate in a more cohesive manner, that's perfectly fine. But from an architecture perspective, we segment them out in source control so that we have each microservice truly owning at least one data store that it can use for its purposes without any interference from outside parties.
One last question on the database thing for now. David Alpert asks, how would a schema update script strategy like this handle moving back and forth between branches where you might take a local database from version 3 to 4 and then to 6 and then to 5 where the source code or build for 6 doesn't have the update script for 4 or 5 or something like that?
That's a good question. So typically when you're working on your local dev environment, and you can see when you download our Git repo, one of the things that we do when we do a full build, we wipe the database, our local instance of the database, so we start over. And that means it's going to start over with whatever scripts are available in that branch. So we just kind of start fresh. And you can also add seed data and test data that can run it on your local development machine that doesn't run in production to still seed that information in there. So it works very well with branches because you're only creating what the database is at that state in time.
Yeah, that's right. Really, when you're talking about data and databases, once you get to QA and staging, and well, not QA, but UAT and staging and production, you're on a one-way track.
Right.
You're going up. If ever you find yourself needing to go backwards, well, that's what a database restore from a backup set is for. There's no automation tool under the sun, and we have looked. There is nothing under the sun that goes backwards from a database perspective, because as soon as you have a migration script that deletes a column, well, guess what? There's no going backwards because you have to restore some data that's gone.
Right. And that will bring in some other things that we can maybe talk about in the last Q&A about separating out additive versus destructive migrations and things like that. Let's go.
So the next pitfall is making everything public. We're dealing with messaging. We're coordinating between microservices with NServiceBus, and so we're publishing commands and sending queries and events. And so making everything public is a pitfall that's actually, unfortunately, far too common. So it's a well-worn pattern to put messages in a particular library that can be shared with other microservices, and sometimes they're published in a team-level NuGet feed or whatnot. But if all of the messages are put in that library and shared, then essentially everything is public, and you end up with a tangled mess of dependencies, or the 2016 version of dependency hell. And if you have even as much as one long-running business workflow in a particular microservice, and you've implemented it as an NServiceBus saga, well, sure, the command or event that kicks off the saga will come in, and it is public, and it is shared, and it comes from somewhere else. But the intermediate steps, the messages, possibly commands and replies that represent other steps in the saga, those should be internal to the microservices only and should not be shared with other ones.
Right, because a lot of messages and commands that we create, we're doing that so we can take advantage of the durability and reliability of the NServiceBus infrastructure. So we break up smaller pieces of work inside the one service just so that if it shuts down, if there's an error and that service crashes, we can just resume from where we were, much like if you're paging something from a document or something like that. So our guidance here, we want to look at creating boundaries around your services. So we typically look at grouping some microservices together by capabilities, and we can add a logical boundary around that. And so within that boundary, we can share commands and we can share private implementations. But outside of it, we want to mainly either communicate by events or very, very specific commands where it makes sense. And if we don't do that, you end up with something like this. This is, I know the resolution is about a potato quality, but this is the Death Star architecture that you probably have seen a couple of times before when we look at microservices dependencies. Each one of these little green and blue dots represents a service, and there is a blue line going to its dependencies. We want to avoid this. So we want to start grouping some of the microservices and not allowing other people to talk to them because there's no need. It's the same reason why we make some methods private. We break them up to create a different level of abstraction so that we can test it differently, so we can maintain it easier. And we do the same thing with microservices too. We create an additional service that can handle something else for us, but it doesn't need to be public to everybody else all the time.
Yeah, so I've done a lot of NServiceBus training, and I kind of see this with beginners in NServiceBus as well. One of the first mistakes they'll make is they try to put all of their messages in one big messages assembly, and they're shared throughout their entire system. What we really counsel people to do is to think about what should be public and what shouldn't, and to divide them up. So each microservices could have one assembly that contains all of the commands that are kept private to the microservice, and those aren't even shared outside of that repository. And then you have another assembly that's called microservice.contracts, and that contains the events that the other microservices consume. And then you can take that assembly and you can deploy that as a NuGet package on a private NuGet server or on MyGet or something like that. And that allows you to kind of make those boundaries so that endpoints can't be expected to handle commands given to them outside of the service boundary.
Yeah, this is all about managing dependencies, and this is so important in lots of different places. I want to come back to the point after Justin shows you.
Sure, yeah. So here's just an example. Within the Git repo, you'll see an order.contracts, which has an order placed event. And so this is public. We can announce to the world that this is going on, but we do not allow just anybody to send a place order command. So this is something that the order processor holds onto and can share it with the order UI. So this is all one microservice.
And so dependency management comes into play with databases, with libraries within Visual Studio Solution, and definitely at the microservice level. So with big databases, probably everybody on this call has had a scenario where you had a foreign key from one table to the next table, and then to the next table, and to the next table, and somewhere along the line had a foreign key back to the original table, and you end up with a circular dependency, not one that's small, but a large-scale circular dependency where somewhere along the way you said, in order to delete a record, we need to make one of these foreign keys nullable so that we can null it out and then not work with this circular dependency. The problem is not you make a foreign key null. The problem is you actually created a circular dependency in your architecture. And so when we think of dependencies, whether it's domain-driven design, whether it's in database tables, or whether it's microservices, your dependency graph needs to terminate. So your dependency structure needs to be more like a tree than a graph. If you have a tree, then no matter where you go, you will get to the end. If you make your dependencies like this Death Star, then you can keep jumping along the lines of dependencies and literally never stop, and you'll be in an infinite loop because you haven't given the proper thought to your dependencies. So when you put all of these microservices together, You should be able to draw your entire system of microservices with the dependencies depicted as lines between them and be able to see it as a tree that does have a termination point. And in that way, you'll have something that's manageable going forward, and the things that are shared are the messages, and you don't end up with a large-scale circular dependencies that are going to make your life and your team's life very difficult for a long time to come. So we'll move on with coupled deployments. So you're going to have multiple microservices in the system. That means you will not have one system deployment or one schedule, and you will not deploy every microservice at the same time. If you do have a situation where when you change one microservice and then you redeploy every other microservice in the system, then in reality, you don't have microservices and you might as well put everything in one Git repository, because you really just have one unit of deployment. Because when you deploy something together, well, it's coupled. You split out system elements as microservices because it needs to have different production characteristics. Maybe it has different uptime requirements. Maybe it has different security boundaries or security requirements or performance level or scale level or any number of differences, but they're always production concerns that cause you to decide to create something as a separate microservice. Microservices are not a unit of layering. If all you need to do is layer the code and have some separation of concerns within a particular application, then just break out some separate projects in one Visual Studio solution. If you need different characteristics in production, then you create separate Visual Studio solutions, each encompassing a microservice and each having its own Git repository. So you need to expect that you're going to have separate continuous delivery pipelines for each of the microservices, and they are going to have a schedule and a life on its own, and you should expect one to maybe, if it has a REST API, it's going to maybe need to have super high uptime, so you're going to need a web farm to facilitate that. Whereas another microservice that may encompass just a back-end batch job that runs a couple times in the middle of the night, doesn't even do anything in the middle of the day. So if they have very different production characteristics, then they need to have decoupled deployments because they're going to be different.
So right here, make them independent. So you want to start versioning your APIs from day one. That doesn't mean you have to have a V1 inside of your URL or whatever scheme you decide to go with, but you as a team need to agree how you're going to version your things. And when microservices first started becoming the big thing, one of the things about it was that you can HTTP everything, right? Because HTTP, every language that's modern that we use, all under, has a library that can make HTTP requests. But we want to focus on passing messages unless there's particular reasons why we want that request response. And this is another reason or another way that we can start to make them independent, especially using messages on the NServiceBus infrastructure. So if you make a deployment to one of your microservices that is accepting events or commands, while it's down, the queuing infrastructure behind it is still just collecting all those messages. So when it comes back up, it can pick up where it left off and you don't lose any data. There are different tools and such that you can use to help facilitate some of this. Consul is a tool that we've used before and had a lot of success with. It's a distributed key value pair. There's Nginx, which is a proxy, and you can use DNS to also help mask the locations of where microservices are, so you're not hard coding locations. So if one goes down, you can bring up another one in this place with just a different IP and update your DNS.
It would be very useful for everyone to have an idea of what kind of rules of thumb to choose HTTP and to choose an actual message being passed along a queue. So within a system where we have multiple microservices, we have a team organization, we have some system conventions, and we've chosen NServiceBus for asynchronous message processing. We've chosen other elements of our technology stack and some standards so that while the microservices can vary, we have consistent conventions between them so that if developers need to jump from one to the other, there's no problem. We have collective code ownership. Within a particular system, we can choose to have certain conventions around asynchronous passing of data, asynchronous messaging, and we can choose that we're going to use the same version of NServiceBus throughout the whole system, and if we upgrade, we kind of look at compatibility. Now, what about web services? When do we use web services? Because it may be appropriate to use a synchronous and blocking HTTP call from one microservice to the other, if that makes sense. But another key area where you're likely to need to use HTTP rather than messaging of any kind is at system boundaries. And that is where a microservice is on the edge of the system and is responsible for integrating or interacting with a different system, something that you don't control. And in those boundaries, compatibility is a much greater concern. Within the system, you control all the microservices, and so if you want to migrate a communication protocol or convention of any sort, you just talk with the team, you do it, it's great. But if you're integrating with a system you don't control, then you have to drop to the lowest common denominator, which is either passing a file or sending some information over HTTP, a web service of any kind, whether it be SOAP or REST or JSON or XML. And so it's perfectly valid for a microservice to literally have the responsibility for integrating with the next system over. And it may call their web services, it may expose web services and interact in a highly compatible, lowest common denominator way using HTTP with that external system, but then translate the data and then pass an asynchronous message to the other microservices within the system or publish an event within the system. So that's a very valid scenario. The next pitfall is automation as an afterthought. So the problem that we run into sometimes is first microservice gets stood up, it's great, it's simple, it's easy, the team may be in a hurry, and so we don't set up a continuous delivery pipeline. We set up the servers from scratch, kind of remote desktop in, configure those, and then we go to set up the next microservice, and then we don't have any build automation. We don't have any automated deploys. We don't have any automated server configurations, and we end up with every server being its own unique snowflake. There's Jeffrey Snover from Microsoft has made popular the pets versus cattle approach when talking about individual servers, whether they be Hyper-V or VMware, as to cloud services, and then ongoing to platform as a service. So that approach is the analogy where in the scenario for pets, if you treat a server like a pet, you give it a name, you know it intimately, you spend time with it, you're very, very familiar with it, and it's a big deal, right? In the cloud world or in the automated infrastructure world, we treat our servers as cattle. We number our servers. We don't name them. We don't really care about them intimately. If one goes away, we just press a button and replace it with another one. And it's much more like a herd of cattle where, okay, you got a herd of cattle and each one has a number. And in that way, we can spin up a new environment, and it's very, very easy. Now, if you're deploying to a cloud-based platform as a service or serverless infrastructure environment, then the analogy is going even further, and in the future, we'll start treating servers like chickens, where we don't even number them, but we merely count them.
All right, so our guidance here is